First, can you start writing? So if I have two vectors, then if I want to find A cross B, if I want to find the cross product of these two vectors, let us put in the determinant form. So the coefficient of I cap, J cap and K cap for vector A, and for vector B, I'm specifying that. See, the cross product A cap, B cap, sorry, A cross B vector is also a vector. The cross product is also a vector. So this vector C should be expressed in terms of I, J, and K cap. So how will I go for it? Are you clear, boys? The cross product of these two vectors is also a vector. So that vector C should be expressed in terms of I cap, J cap, and K cap. Have you completed? So 1 second, I'll make a new slide. Have you completed till this, boys? Have you completed?
Yes, ma'am.
Okay. So let me go for how to find. So A cross B vector must be equal to I, J cap, K cap, AX, B, sorry, AY, AZ, BX, BY, BZ. So now this I can write it as, so leave whatever is, I'm just highlighting, was leave this part.
This is all under modulus, right?
Yeah, actually we call this as the determinant. Okay. So what you need to do is you have to leave this part. So what is left is AY, AY, AZ, BY, BZ into I cap. Yeah. So just what is below I, those things you have to leave. So what is left is AY, AZ, BY, BZ. Is that clear, boys? Is this clear? 11B.
Sir.
Okay, next I have to go for finding the coordinate, sorry, the coefficient of J cap. For that, just whatever is below J cap, those elements should not be included. So below J cap, you have AY and BY. So I should not use that. What is left is AX, AZ, BX, BZ. Is that clear? So whatever is the column below J cap, those elements should not be included. So what is left under I cap as well as under K cap? So those elements I'm writing. Just look whether it's correct or not. Just check, boys, check. Are you able to understand? Next, I have to go for K cap. So whatever is below K cap, those elements should be neglected. All the elements below K cap should be neglected. So what is left? AX, AY, BX, BY. Is that clear? So all below K cap should be neglected. So what is left? AX, BY, AY, BX. Is that clear? Is that clear, boys?
Yes, ma'am.
Copy down. Okay, copy down. Then I will go how to solve this. Copy down, boys. Now, once you have copied down, then I have to teach you how to find the coefficient of I cap, J cap, and K cap. Now, this is the method of finding, because I'm just putting an arrowhead. So you have to multiply in such a way. It comes, the left quantity comes first. So it will be, I can write AY into BZ, AY into BZ. Do you understand what I'm doing? AY into BZ minus, then comes the other one, the right arrow. So AZ into BY, that into I cap. Is that clear? When we are doing numerical, you'll find it better. So AY, BZ, is that clear, boys? First, I'm going for the left arrow, the arrow which is moving from AY to BZ. So AY into BZ minus AZ into BY. Next, I have to go for J cap, minus of. So what is there for J cap? It is AX into BY. So AX into, BZ. Are you clear? I'm just doing for J cap, AX into BZ minus AZ into BX. So this, the whole into J cap, plus AX into BY, AX into BY minus AY into BX. This is the general notation. This is the general way of doing. Once we put the numbers, then you'll understand it better. So AY, BX. Is that fine?
Yes, ma'am. Yes,
so we'll go for a number. This is the general way of writing. Have you completed? Have you all completed? Okay. So we'll go for the. We'll start with the numerical as a whole. So suppose if A vector is equal to 5 I cap minus 2 J cap plus 1 K cap. So B vector is equal to 3 I cap minus 1 J cap plus 2 K cap. Suppose if this is the case. So you want to find A vector cross B vector. So let me write this, boys. I cap, J cap, K cap, then 5 minus 2 plus 1, 3 minus 1 plus 2. Anyone having a doubt over here, boys? The first step is fine? Is the first step fine?
Yes, ma'am.
Okay. Now we'll go for finding the coefficient of I, J, and K. So what we'll do is we'll take the determinant form. So whatever is below I cap, you leave those numbers. So it will be -2, 1, -1, 2, correct? Into I cap. Right, boys? So what then? Plus, for J, it should be negative. Minus. So what can be written for J? Whatever elements below J, that has to be not included. The elements which are below j cap, that is -2 and -1, should not be included. So what is left? 5, 1, 3 and 2 into j cap plus. Now we have to go for elements that are not coming below k cap. We have to neglect the elements which come below k cap. It is 5 minus 2, 3 minus 1. Is that clear? 5 minus 2, 3 minus 1, k cap. Are you getting all these things, boys?
Yes, ma'am.
Okay. Now we'll start multiplying. So it should be -2 into +2, because I'm just multiplying from left to right, then minus of these two together. So that will be 1 into -1 I cap. Is I cap value correct? Then I have to go for j cap. So it will be for j cap, it is minus of 5 into 2, then comes minus 1 into 3 j cap, then plus 5 into -1 minus 2 into -2 into 3. So that will be k cap. So totally, what will you get, boys? -2 into +2 minus 4 minus of -1 I cap minus 5 into 2 is 10, 10 minus 3 j cap plus 5 into -1 minus 5 minus into minus plus 6 k cap. So now what is this value? -4 plus 1 I cap minus 7 j cap, 10 minus 3 is 7, plus -5 plus 6 plus 1 k cap. So the final vector will be minus 3 I cap minus 7 j cap plus k cap. This will be your final answer. Are you able to get this?
Yes, ma'am.
I'm hearing only from one student.
Yes, ma'am.
If one more numerical is
Yes, ma'am.
being
I got the
given
same
to you,
answer.
okay. If any other numerical to be given, will you solve? I'll solve. I'll ask you to solve one, and then we'll go for a new concept of torque. Have you completed, boys? Shall we proceed for the next numerical?
Yes, ma'am.
Shall I go for the next slide? Or you need me, or need some more time? Do you need some more time, or should I move for the next one?
I posted a screenshot in the chat.
Okay. So have you taken the screenshot, boys?
Yes, ma'am. You can go to the next slide. Yes, sir.
Can you do this? Let us see. Find the two vectors are given as R vector is equal to 2I cap plus 3J cap. Anyway, this torque you will be learning it later. This is called torque. That you will be learning it later. You find R cross F vector. So first write it in the determinant form was I, J, and K. Okay, I'll call someone. 11B.
Can you give us a minute so we can do it first?
Oh, okay, so fine. I'll just write it in the determinant form. You please try to do.
Ma'am, is it necessary you have to write it in this matrix form?
No need. If you can
Ma'am, we can
directly,
directly do it.
yes, you can directly. Just keep your fingers, finger across your J, block the column J, then you can easily do. If you keep your any one of your finger blocking the Jth column, then you can see only I and kth column. Then 2 into 4, 5 into 2 into 4 minus 5 into 3. Same way, you can keep the finger and block that particular column.
Okay.
Or else feel that is difficult. So you first keep your any one finger across along your jth column, so that what you can see is 2, 5 and 3, 4. So 2 into 4, 8 minus 5 into 3, 15. That's into I cap. Next, for sorry boys, sorry. First for the I cap, you have to block the ith column. So keep your fingers across the ith column, so that what can you see is 3, 5 minus 2, 4. So 3 into 4, 12 minus of 5 into minus 2. So into I cap. Next, when you are learning, when you are finding J cap, keep your fingers block the jth column, so that you can see 2, 5, 3, 4. So 2 into 4 minus 5 into 3 J cap.
Ma'am, I got the answer.
What is your answer?
Ma'am, I'm getting torque is equal to 22 I cap plus 7 J cap minus 13 K cap.
Very good. May I know who is, because I'm just in the slide. Who is that?
Ma'am, Ayan.
Okay, that's correct, boys.
Ma'am,
Yes.
ma'am, is there a difference between cross product and vector product, or is it the same thing?
No, vector product, vector product, you have two types of vector product. One is cross product, the other one is dot product. Boys, your vector, sorry,
Okay.
one second. So vector product, so you can have two types of vector product. One is your cross product, the other one is dot product. So if I say W is equal, sorry, W is a scalar one that goes over here. W is equal to F vector dot S vector. So W is equal to Fs cos theta. Now here, the final quantity W, that is the work done, is a scalar. You have two vectors. The dot product of two vectors is a scalar that comes under your scalar product. Now this is cross product, right? Now under cross product, A vector cross B vector is equal to C vector. So the resultant is a vector. So we can say this is equal to AB, sorry, the magnitude of this vector, that we'll see how the magnitude comes to be AB sine theta. The magnitude of the vector, if I can put it this way. So cross product, both the vector product of both the vectors will be a vector itself.
Ma'am, are both of them commutative? As in for cross product, if I do B cross A and A cross B, is it the same thing?
It will be slightly different, boys, because we'll start doing it, then you'll understand. Once we'll complete that, you'll be able to understand. Is it communicate? All
Ma'am?
those properties will do, yes.
Ma'am,
But it
for
takes a
the
long
G-
time. Yes, boys.
Sorry,
Just
ma'am,
can you
sir.
check? Yes, yes. I'm not able to hear. Are you getting the same answer?
Ma'am, I have a small doubt.
Yes, yes.
Ma'am, for the J cap, shouldn't it be 8 minus 15?
Yes, ma'am.
Is that so? Wait. So J cap minus of, I'll just write 2, 4. Wait, boys. The problem is what they have done, I'll tell you. 5, 3, right? This is J cap. I'm just only doing J cap, right? So it's minus of 2 into 4 minus 5 into 3 J cap. Okay. So minus of 8 minus 15 J cap. So that becomes minus of minus 7 J cap. So that comes to be plus 7 J cap. They have taken the sign plus outside. That's the reason. It will be plus 7 J cap.
Okay, ma'am.
Don't change the order, then it will be tough for you. Only thing is for J cap, you'll have a negative sign outside. Might be this answer. Only just check the answer, boys. You don't change the order, then it will be tough for you. So others are all of you are getting the same. B.
Yes, ma'am.
So cross product, you will try various other numericals, so I can move on to the next topic. Is that clear, boys?
Yes, ma'am.
Okay. Next, it is torque. Please write a new concept, what we call it as a torque. Now, generally, what do you mean by torque? Torque is nothing but a force which is capable of rotating a body. Torque is a twist or turn that tends to produce rotation. So applications are found in many common tools around the home or industry where it is necessary to turn, tighten or loose devices. A very important concept. The same concept is going to be carried over to grade 12 also. So what do you mean by torque? Torque is a force which makes a body to rotate. So it will cause a rotational motion of the body. We call it as torque. So we will just find the definition for torque or how to measure a torque, right? And then we'll go for the vector notation of your torque. Now, the simplest example of torque is nothing but how to measure your torque. Your aim is to, what is torque? Torque is nothing but a force that causes the rotational motion. Now the question is how to measure your torque. How to measure the torque. The simplest example of explaining torque is that you're the opening and closing of your door, right, boys? When you're opening a door as well as you're closing a door, now what is going to happen is you're applying a force, you apply a force, and then you're causing a rotational motion of the door, yes or no? While whether you're opening the door or whether you're closing the door, you're causing the door to rotate. You're causing the door to rotate about an axis passing through its hinges. You know what do you mean by hinge? You know what is hinges? Yes or no, boys?
Yes, ma'am.
You know the hinges. Now your door is going to rotate about an axis which is passing through the hinges, right? So look at this diagram. You apply a force on the knob. Yes or no? If you want to open a door or if you want to close a door, you apply a force on the knob of your door, right? Is that clear, boys? Can you imagine that? Or else what I'll do is I'll just go for the video clipping and then I'll come back. Now I'm just I'll stop sharing and then I'll
Hey guys, the aim of this video is to explain what torque is. So let's go through an example over here on the definition of torque. So let's say we have a door over here. We treat this point, the hinge, as the pivot. So this is the top view and we can think of the door as a lever arm and we have a force when we try and open the door. So this is F, the applied force. And we're also interested in the perpendicular distance from the force to the pivot point. So that would be this line over here. And we call this R perpendicular. So together these two parameters give us our torque, which is this force times perpendicular distance from the pivot point. We can also think of this experiment in a real life situation when you try and open a door. If you try and open a door and try and push it from over here, you would find that it's much more difficult to actually open the door from pushing it here with the same force as here. And if you try and apply a force to the hinge of the door, you will find that the door will not even move. And this is because while the force is the same, R is now 0, the distance from the pivot point. So you're basically applying 0 torque to the door. Likewise, if you apply a force over here, remember our definition for R, it must be the perpendicular distance. So if you apply a force into the hinge, you will find that there's also no rotational movement because the force is acting on the line of action, so parallel to the line of action. So these two cases, one force here and another force here, would yield 0 torque. So let's go through this example with some numbers. Let's say we have 5 newtons here. And this door is 0.75 meters. The torque is quite simple to work out. The torque is now just F times R, so 5 times 0.75. And this works out to be 3.75 Newton meters, which is the units for torque. Again, let's quickly work out the force acting here. So the same force, 5 newtons, and this distance, let's say, is 0.2 meters now. So our torque in this case would be 5 times 0.25. So this would be 1.25 newtons meter. As you can see, the rotational force when applying a force closer to the pivot point is much less. And you can also try this experiment on a door that you have in your house. Try pushing it closer and closer to the pivot point, you will find it's much harder. And if you push exactly on the pivot point, you would find that you have 0 torque, which means the door will not even rotate this way.
So we'll start with, is it time up, boys? Just check. What do you have next period? Maths, okay, okay. I think so. It's time up. So you can leave, boys. So, yes. You want the talk slide? Okay, I'll read the talk.